Assalamu alaikum. Dear students, this is chemistry 11th, and our today's topic is Bohr's model of atom. Dear students, as we have already discussed various models of atom, we have discussed Thomson's model of atom, and since that was because of its limitation, this Thomson's model was rather rejected, and it was then replaced by, then came Rutherford, who gave his model of atom, and that too was also rejected because of its limitations. Then the limitations of Rutherford's model of atom, where we have told you that he said that there is a continuous loss of energy when an electron revolves around the nucleus, and it assumes, while revolving around the nucleus, by losing this energy, it assumes a spiral path, and until it falls into the nucleus. Similarly, another limitation, that it could not provide any explanation to this spectrum of this line spectrum of this hydrogen atom, where we saw a different series of lines grouped together in different regions of the electromagnetic spectrum. Now, in order to overcome these limitations, or in order to overcome the limitations of Rutherford's model of atom, Niels Bohr in 1913 proposed a new model of atom, and this model of atom, it was based on Planck's quantum theory. The main postulates of Bohr's model of atom are: number one, Bohr said that electrons revolve around the nucleus in well-defined circular paths, which he called as orbitals. This was the first postulate given by Niels Bohr. The second postulate of his model of atom, Bohr's model of atom, is that each orbit is associated with a definite or with a fixed amount of energy, and he therefore called it as energy level or energy shells. He called these orbits as energy levels or energy shells, and these energy levels, these are numbered. They have been numbered from 1 to infinity. However, the values from 1 to 7 have been given to accommodate the electrons of known elements. Now, these orbitals are also designated by letters K, L, M, N, and so on. Now, third postulate third postulate of Bohr model of atom, or Bohr's model of atom, is that he said that as long as an electron continues to revolve in its own shell, that means as long as an electron remains in its own shell, its energy always remains constant. That is, it can neither lose energy nor it can gain energy. So he called these energy levels as stationary states, because the energy of these energy levels, it remains fixed, and so the energy of the electron also remains same as long as it continues to remain in a particular energy level. Now, the fourth point of Bohr's model of atom is, or the fourth postulate of his model of atom, is that as long as an electron continues to revolve in its own shell, as long as and continues, that the energy remains its energy remains constant. However, an electron can lose or gain energy only by jumping from one shell to another shell. That means it can gain energy when it jumps from lower to a higher shell. That means when it goes to the higher excited state. In that case, it absorbs energy, or it can gain energy. However, it can lose energy only when it jumps from higher shell to the lower shell. That means it comes from excited state to the ground state. This energy which is gained or which is lost, it is lost or gained in the form of small discrete units known as quantas, and the amount of energy lost or gained is given by delta E is equal to E2 minus E1. Here delta E, it represents the change in energy, and E2 represents the higher energy level, and E1, it represents the lower energy level. Now the amount of energy that is given out, or that is absorbed, it depends upon the difference between the two energy levels. So that means the energy of the electron is also quantized. It means that it is the loss is not continuous, rather it is discontinuous. Now the fifth postulate of Bohr model of atom is that he said that electron can revolve only in that orbit where its angular momentum is an integral multiple of nh by 2 pi. That means only those orbitals are permitted which have angular momentum where the angular moment of the electron is equal to nh by 2 pi, or we can say the angular momentum, that is mvr. The angular momentum of electron is given by nh by 2 pi. Here n is an integer, it has got its values 1, 2, 3, 4, and so on. Now m, it represents the mass of the electron that revolves around the nucleus in that particular orbit, and v is the tangential velocity of the revolving electron. Now or it represents the radius of the orbit in which the electron revolves, or in which the electron is present. Similarly, this h, it is the Planck's constant, and the English, now depending upon the values of this n, 1, 2, 3, we have got the angular moment of electron can be it can be equal to h by 2 pi when the value of n is equal to 1. Now the value can be 2h by 2 pi when the value of n is 2. It can be 3h by 2 pi when the value of this n is 3, or it can be 4h, or it can be 4h by 2 pi, that is h by pi, and that is 2h by pi when the value of this when the value of this angular momentum, when the value of this n is equal to 4. Now from this it is clear that the angular momentum of the electron is also quantized. So these are the various postulates of the Bohr's model of atom, and 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 this is for today. I hope that you have understood these postulates of Bohr's model of atom. Thank you very much.